Four coplanar forces of magnitude 4, 8, 12, and 16 act at a point. The direction in which the forces act are shown. Find the magnitude and direction of the resultant of the four forces. Okay, we're talking about this figure first. Let's say resultant is somewhere over here, and the angle it makes is alpha. We have to find the value of R and alpha. Okay. To find R, we have to apply Pythagoras theorem on its x component and y component, and x component is found by adding all the x component of these four forces in one direction, and if there's an x component of any of these forces in the opposite direction, that gets subtracted. But in this question, all the x components are in towards the right, so nothing will get subtracted. So the components are 4 and 8 cos 30, then 12 cos 60, because this angle is 60, and that's it, because 16 Newton has no horizontal component. So for Ry, we'll do the same. We're going to resolve all the forces, all the four forces, get their vertical components, and then add the ones in the same direction, subtract the ones in the opposite direction. But again, in this question, all the horizontal forces, or sorry, the horizontal component are upwards, so the direction is the same. So there will be no subtraction taking place. So there's 16, then there's 12 sine 60, then there's 8 sine 30, and that is it. The 4 Newton force has no horizontal component. Okay, now we square these and add these. So I am going to find these individual values first. 4 plus 8 cos 30 plus 12 cos 60 gives 4 plus 10 plus 4 under root 3, and 16 plus 12 sine 60 plus 8 sine 30. That is equals to 20 plus 6 under root 3. Okay. Now R is equals to square root 10 plus 4 under root 3 squared plus 20 plus 6 under root 3 squared. Let's see, what do we get? Answer squared plus bracket 10 plus 4 under root 3 squared. And square root the answer. We're getting 34.788 newtons. And alpha would be, alpha is tan inverse Ry upon Rx. Ry is this, Rx is this. Now substitute this or enter the values in the calculator and you should get 60.8826 rounded to 60.9. Okay, so first part is done. Second part says that the forces of magnitude 4 and 16 Newton exchange their directions, and the forces of magnitude 8 and 12 Newton also exchange their direction. So now they're talking about the second figure. Okay, so 4. So basically notice that this has gone here, this has gone here, this has gone here, and this has gone here. So it has like completely rotated, or you can say in a way, flipped in this direction. So 4 Newton was originally horizontal, now it's vertical. 16 was vertical, now horizontal. And 8 Newton force was originally here, now it's above the 12 Newton force. So now the resultant should not change. The question is saying find the magnitude and direction of the resultant force. The resultant is not going to change because all these forces are the same. So the value of resultant is going to stay the same. We said the resultant was somewhere over here. We had assumed it. And in fact, we know the angle of the resultant 34.7. So let me, yeah, it should be somewhere over here. slightly above the 30-degree angle. Okay. And also we know its magnitude. Now this uh, resultant this angle was 34.7. Now this resultant force will be somewhere over here, and this angle would be 34.7. So instead of redoing all the steps you've done in part one again and getting these answers, you can just use the theory we just discussed, that since the values of the forces did not change, the resultant's magnitude will not change either. So you'll get the same answer, 34.7 newtons. For the direction, yes, the angle will change. Now we're going to write 190 minus 34.7. This will be the angle. So 90 minus answer is 55.2. And what is the direction? Clockwise, 55.2 degrees clockwise, or you can write above the 16 Newton force. Clockwise above, or I believe just writing above the 16 Newton force would work as well.